All right, what's up? This is Print Practical here for a little drawing session here on a Friday night. I've been doing a series on YouTube where I am designing different things and putting them up on MakerWorld, and the goal is to get enough credit in MakerWorld to buy a new printer. Right now, I'm at like the $400 range. I've only made one video so far in the series, which was a gift box. It was a box that had a bunch of screws in it, and you could put a gift card or something in it. And that's doing okay. But my other two like big models seem to be driving most of the revenue there. So today we're gonna try and draw at least part of one of my next models that I'm going to be putting up on MakerWorld, and that is going to be like a fidget toy. You know, scanning over MakerWorld, I've noticed that a lot of people download like little trinkets and fidget toys and stuff like that. That seems to be a very popular thing that people with 3D printers print. So I want to use this as a learning experience, and I want to design kind of a cylindrical fidget toy that has a push button just like a pen. So I want you to be able to click it and it engages, and then click it and it disengages. Obviously nothing's going to pop out of the bottom, but I just thought it would be nice to have, you know, a nice cylinder that you hold in your hand and you just have a button that you can click on repeat. You would think that's easy. I've been looking into it for a few days now on like how a pen works, and it's actually pretty complicated. And it's interesting that, like, you know, all of us walk around with a pen in our pocket, but you don't really know how it works. I do have a reference video by somebody on YouTube that I will show in a little bit, but I want to just get started, start modeling, and the goal is, you know, if you're in here and you're watching, that's awesome. Feel free to just like enjoy watching me model, or if you have any questions or anything about 3D printing or anything like that, feel free to just drop it in a comment below. But yeah, so I'm gonna get started drawing like the body of this fidget toy. So let's hop into it. Always gotta have a beer on hand. I really hope that my audio and everything's working fine. I did a live stream probably like 6 months ago now. I was gonna start live streaming me modeling things, but then I just lost track of time. But I did one live stream and the audio was totally messed up, and it turned out to be a huge fail. So if you are watching this and you can hear me, that's great. If you can't, it would be awesome if you could at least put something in the comments to say that you can't hear me, because then, well, I guess you wouldn't hear me at this point. But all right, let's hop into it. So I'm gonna try and like parameterize this model. You know, usually I go off, I start drawing, I use a bunch of references in other sketches and stuff, and then it just gets complicated because you want to go and change one parameter and it screws up the whole model. I've been learning as I've been drawing in Fusion and just like 3D modeling in general. It's definitely an art. It's just like I can relate to it because I'm a software engineer during the day, and you know, when you're writing programs, the whole point is to design them to be flexible. So when requirements change, then you can easily adapt to that. So, you know, modeling, parameterizing things, it's kind of like writing a program. You know, you want to make your model flexible so that if the requirements change, you know, you want to change the size of a part or something like that, everything else should just adapt. So I'm going to make a cylindrical case, and I'll make that like 30 millimeters. And I'm just going to throw out some dimensions. And then, you know, I have printers set up, and I will throw them on the printer. You know, we could throw partial models out on the printer, and we can start printing things to see, do they feel good? Do we need to adjust things? Yeah, thanks. Is that Chuck? Yeah. And I just accidentally clicked on your message and retracted it, I think. So, my bad, Chuck. Alright. So, if you're just joining in, I'm doing a series on YouTube where I am designing models and uploading them to MakerWorld. MakerWorld pays you out as people download your models and print them on Bamboo printers. So the goal is to get a free printer in the end. I did one video so far with a gift box, and that's doing okay. And my other models are carrying me as well. I'm at like $400. But right now I'm making a fidget toy, because it seems like everybody wants a fidget toy, and I want to make a pen, like a pen click button. So that's the goal. So let's actually get something on the screen here. Before I do that, I want to make a new component. This is going to be our case. And we're going to make that the diameter. And we're going to extrude that the height. Now we want to probably fillet the edges here. Make that 3mm. Like I said, we're just kind of throwing down parameters right now. We'll decide later on if that's what we want. So far, we're looking good here. Looking good. So, if you don't know how a pen works, there's like 4 pieces to the system. Let me pop this pen apart here. It'd be helpful if I could see my camera here, so I know if I'm showing the right things. Alright, so I got my pen in pieces here. Here's the bottom part of the case. Top part of the case. Really all that matters is the top part of the case, the tube that has the ink in it. The spring plays a crucial role. And then you have these 2 pieces at the end, which we have a cap. And you can see it's got these little prongs on it. That's pretty important. And we have a cam. Man, it's really hard to see the details of that. But anyway, so the cap interacts with the cam. It pushes the cam up and down. And those teeth on the cap, and there's slots on the cam. When the cam gets pushed to a certain distance down into the top tube, it makes the cam twist and fall into the next hole, and that makes the click of the first click of the pen, and it holds the, you know, the writing part of the pen out of the end of the case. We're pretty far away from this part. We still got to draw, you know, the case. But one thing that I was trying to bring up while I was breaking down this pen is that, you know, the case is hollow. So we're going to have to make this case hollow. We're going to have a piece that comes off. So we'll have to make like the bottom screw off. And then once we draw that, we'll draw a button And then that's where the really technical stuff starts. And then we'll, you know, watch a video of somebody breaking down how a pen works, and we'll try and draw it. Hopefully we can get to that today, but like, this stuff is complicated to draw for somebody like me who's like not a pro at Fusion. So let's hop in. We have the case drawn, so we probably want to shell this out. Like I said, it's hollow in the middle, and let's parameterize that. We'll shell it out to 5 millimeters for now. What's up, Spank Ranch Garage? Glad to see you can make it here. Spank Ranch Garage, I was talking to him actually about designing this piece, and it's definitely complicated. And we were realizing that you know, you don't appreciate the intricacy that comes with something that's as simple as a pen. So now we hollowed out our case, and we can verify that. We're going to add a section analysis here to our case, and we'll put it on this plane. So as you can see, it's hollowed out. Man, I don't have beer in cans here. I'd snap one for you. Anyway, all right, let's turn off the analysis. So now I need to make the bottom screw off. That way you can put the components on the inside. So let's do that with a plane. And I'm gonna throw another parameter in here. Yeah, man, gotta stay hydrated. Yeah, so I was saying earlier, Spank Ranch, that, you know, people don't understand how hard it is to draw things in CAD. Like, you could whip something together, but like to really draw a nice parameterized model it's an art. I really like it. I relate to it because of programming. But yeah, it's definitely a hard thing to do, and I'm trying to be better about like writing out parameters, using those parameters instead of referencing other parts of sketches, or, you know, when the other parts of the model change, like sometimes those references don't change and it breaks the whole model. Oh, thanks for letting me know that. Jeez. That should do it. Let me see. Yeah. I'm not a live streamer, you know, so you're gonna have to bear with me here. But I appreciate you calling that out. All right. So we're going to use that plane to make our bottom cap here. So we are going to split this body, and we are going to use that new plane that we made. And we'll take that body, and we're going to create a component from that. And this is going to be our cap. All right. All right, the next thing we want to do, we're gonna need to make a way of connecting this cap to the case here. So we're gonna have to make a threaded section. Now, Spank Ranch, this might be a place where you could give me some advice, um, because this is so like my goal is I want to make this look nice on the outside. So I'm gonna put a knurled um, look on the outside of the case. And when you do that, I want the bottom to align with the knurling when you screw it in fully. So I noticed that if I make an extrusion out of this cap, and then I make an extrusion, or I make a hole in the case, and then I thread both of those, that doesn't necessarily mean it's going to line up. Like, for example, I have this toilet paper holder that I designed, and I noticed, like, this is the way that it's supposed to be upright, but I noticed when I fully thread it in, it puts my lip on the bottom, and I figured out a way to fix that model to make it appear like that, but I didn't like how I did that. There's got to be a better way to align those pieces. So what I was thinking is that I would draw case diameter, case shell divided by 2. Let's see. I'm trying to put my thoughts together, but to explain this to you. So yeah, I was thinking if I extrude this up and then I put threads on that surface, and then can I use that to just cut out the threads on the body, so that way I know that the threads align with the threads on this cap. I know that there's a built-in tolerance with threads and stuff, so that wouldn't quite be there. I'd probably have to offset some faces and stuff to make it work. I think I'm just gonna try it here and see if it works. So, let's make the cap thread length. I'm gonna make that 8. So this is my plan here. I'm gonna extrude that out. Yeah, see, I didn't know, like, you know, because, like, I don't know if the geometry of threads are, like, exactly opposite. So, that was something that I was concerned about. 25 by 2. Let's model that. Yeah, so here's my goal here. Wait, what the heck? Oh. I accidentally made this sketch in the wrong component. I don't know if you could just drag that down. Probably not. Alright, well, I'll at least make the extrusion in here. So, cap thread length. There we go. Okay. Yeah, so here we go. So we're going to thread this. Create thread. 25 by 2. Model it. And then we're going to make this body appear again. And we're going to combine that with tool body, keep the tool, and do a cut. Now, make the cap go invisible, so that puts our threads on the inside of this. All right. Let me. Yeah, I want to offset the faces here. Let's. Let me play around with some values first, just to see what's realistic. Cause like, here's a good way of viewing it. See, right now there's no tolerance at all, so like, that's definitely not gonna work when I print it. Whereas if I did a thread, an inside thread on this part, like there's probably in the spec for the thread, it's probably a built-in tolerance, which I made a video on adding additional tolerance to threads. That's pretty helpful for 3D printing. If you are interested in that, you can look at the channel. But we are going to add some tolerance ourselves. So I'm gonna push. Oh man, that's very hard to see, but I want to push the top of the thread, like the peak of the thread, and the inside part of the thread inward. Oh boy, what just happened? So 0.2 works, 0.3 doesn't. Yeah, it's because it's like taking the same path as the threads inward. If you have any advice on that, let me know. But that's definitely not ideal. I mean, I'll push these inward as well, and I'm not done yet because I also want to press the surfaces of the thread inward. There we go. We're starting to get a tolerance now. That's looking a lot better. Yeah, so I'm gonna press pull this surface to get that tolerance up top. That looks good. Is it gonna 3D print though? I think I'm gonna add I think I'm gonna add a little bit of a tolerance to the cap too. See. Oh, of course I'm not using parameters like I said I was going to. But the thread is going to change. Whenever you change the size of the shell or anything, that's going to change. So it's going to really need some manual work to begin with. So I wonder what that... Is there a way to just measure an arbitrary... Yeah, probably not. Well, what I could do is I could actually, while I'm working on the rest of the design here, I could throw this on the printer just to see if this thread is going to work. So here's what I'll do. Let's take a quick break on this, and let's export some files. So I'm going to turn that body off. We're going to export this as cap. Oh, wrong format. And we're going to take away that, and then also I'm gonna just quickly cut this body just so I don't have to 3D print the whole thing. So we're just gonna export that. Oop, not cap. Okay, then I'll Control Z all that. Alright, let's see. We want to open up Bamboo. Now I can get fancy here. I do have a feed for my printers as well. So I'll put that here. All right, let's see. So we're gonna open this up and let's get, this is like our cut up case. So we'll put that on the build plate and we will put our cap. What do we got? 36 minutes. That's fine. We'll send that to the printer. Get that going. That'll help us test the threads in the bottom of the case. While that's happening, we'll start working on cutting out the hole for the button and doing all that work. Let's go back to Fusion. Oh, that is not Fusion. All right. Let's start working on the rest of this here. Let's turn off some of these planes too. Alright, so how big is this diameter? 24 millimeters. So let's make a, we're gonna start drawing up the button. So we're gonna do the button diameter. And let's just make it 18 millimeters. Just throwing out random numbers. And then for everything but the threads, I want to make a printer tolerance parameter as well. So any moving parts, any extrusions that ride against each other, I want to have a tolerance for the printer. So we're going to make that, I don't know, 0.25 millimeters sounds good. All right, so we want to make our button. First, we got to make a hole for the button in the case. So I'm going to create a sketch here. We are going to do the button diameter, and we're going to do plus our printer tolerance. And we are going to cut that. Make sure we're only cutting the case. Okay, so it looks like we just about picked the right size. If we would have went any bigger, we would have been digging into the internal wall. So, looks good. All right, back to the main drawing here. Let's create a new component. I see we have a few other people watching, so welcome. I'm just drawing up a fidget toy, or I'm attempting to draw a fidget toy. The goal is to end up with a nice cylinder that you can hold in your hand, click it like a pen. It's part of a series I'm doing where I'm trying to earn enough Maker Lab or Maker World credit to get myself a free printer. So, yeah, if you have any questions about Fusion, drawing, 3D printers, feel free to throw them in the comments, and, we'll talk through them while I'm going through this. I'm going to be modeling this stuff either way, so I might as well, stream it if anybody learns anything. So, we're going to do the button. As you can see, the A1 is working away in its warm-up routine. So I want to make a offset plane so that I can start at the top of the button. Let's go in here and define a button height. And let's make that, I don't know, we'll do 20 millimeters. That sounds a little aggressive, but we'll do it for now, and then we will change it if it looks weird. So we're going to go from the top surface to the button height. And we're going to start a sketch. That definitely looks a little high, but we'll do our button diameter. Finish that sketch. Now we're going to extrude that. And we're going to go... minus, because we want to go we want to go down, and we're going to go the button height, plus we're going to do the shell, and I know I could just say to that inside surface, but I'm just worried every time I seem to reference things, like anytime I change parameters in the model, it just breaks everything. So I'm going to just do it all with measurements. And then we're going to go down the printer tolerance just a little further. Now let's look at the whole thing. I guess that doesn't look too ridiculous. Maybe let me add my fillet too. Does that look ridiculous? I don't know. It looks fine to me. And like I said, once we get all the complicated pieces done, hopefully I get to those tonight, I will make this outside of the case look a lot nicer. I'll do a knurled look. And I'll probably put out a video soon on how to actually draw knurling, because that's not a straightforward thing, but it's very easy, and it definitely makes things look a lot nicer. If you make 3D printed screws and you want to have a nice cap with a knurling on it, definitely makes it look a lot nicer and more professional. All right, let's get rid of the cap. We turn on our section analysis again, just to see where the button is. So now we probably want to extrude this out to this edge with a tolerance, and then bring the button down a little bit. Let me pull this pen apart real quick so I can show what the cap of a pen looks like. It's got these teeth, and I don't really know a great way of drawing it. I have an idea, but yeah, I'm not sure if you can see that. Probably not. Wonder if I can show it on this camera over here. Apparently not. Apparently I can't get anything to focus. But there's a bunch of little teeth on the end of this cap. There's 8 teeth. So, and it looks like all the teeth are symmetrical. So, that's what we're going to have to draw. So, let's get started with extruding out the bottom of the cap here. Going to make a sketch on this surface. Okay. I was just making sure there was a hard edge here and it wasn't like filleted. So I'm going to draw this to be the case diameter minus, and that's going to be 2 times the shell, which should have, that should be my inner diameter of this wall, and then we're going to do minus the tolerance as well. And then we will extrude this. And we're going to go down, I don't know, making up things here. Let's parameterize it. Trying to stick to it. Gosh, if only I could type. We'll say 10 for now. There we go. That looks good. All right. Next thing we got here. So we have the button, which I want to draw the teeth on it. But before I do that, you can see the cam part actually sticks through the button, and then the cam also has a hole in the bottom. And well, actually, this pen's different. This pen, the ink tube just pushes directly against the cam, and it's the same diameter. I've seen some where it goes inside the cam. Well, doesn't matter for now. Right now, we just need to do the hole in the button that the cam will slide into. So let's do that. Let's make a parameter. We're gonna have to make a few parameters. We're gonna make a button cam hole. It's kind of a funny term. Seems like an insult of some kind. The damn cam hole. And we're gonna make the what's the diameter of the button? 18. So we'll make this like 14. And we'll put the tolerance on the button side. That sound right? Yeah. You know what? No, I don't like that. I don't know. Doesn't matter. And then we're gonna do the button cam depth, internal depth, and the button height is like 20 plus, you know, whatever we came inside. So we'll just say 25 for now. If you're just joining us here, we are drawing a fidget toy. You know, it might seem like a simple task to draw something that clicks like a pen, but it turns out it's actually pretty challenging. So that is what I'm doing here. Alright, so we are going to draw this to be the button cam hole. And this is where I was going to add the printer tolerance. Oh, yeah, we'll see what happens here when I go to extrude this upward, but it might actually clip the case, and then we'll have to change the diameter. So we're going to go negative button cam hole internal depth. Oh, it actually looks good. Okay. So we got two more parts of the button that we need to draw. The button is not supposed to spin within the case. So we're going to have to draw some slots that go on the outside of the button. And those will keep the button aligned inside the case. And then we're also going to have to draw the teeth, which is probably a little more complicated. We'll see. I might have to run and grab another beer soon. So let's turn off the case and just work with the button for now. So let's make a sketch. First we'll make some parameters here. We'll do button guide height. We'll make those 1 millimeter. And we'll do button guide width. Make that 2 millimeters, and then we're gonna do button guides, or button guide num. That's gonna be unitless, and we'll do 6 guides for now. So let's draw the guide. So we're gonna make a sketch on the bottom. And then we are going to draw the button internal. Oh, did I just use a calculation to determine the size of this? Let me see where I did that at. That was the hole. Okay. Yeah, I'm actually going to take this and I'm going to throw this in a parameter. That way I can use this dimension in the sketch too. So we're going to do button internal diameter. And then we're going to do plus our guide size, or height. Now we're going to draw a straight line up. Now I'm trying to think of how I'm actually going to make it that width. It's really more of an angle. You could probably calculate that with math, but that seems like a lot of work. So I might just make it an angle instead. We'll pull this up. Yeah, let's get rid of our button guide width. Or we'll change it though. We'll change it to degrees. Or we'll just make it 15. I think I can just use that. We'll see. I don't know how you signify degrees. Like, you can just put a number in there. How do you use a variable for this? Anybody know? I hate getting stuck on stupid little things like this. Yeah, apparently you can't use unitless. There we go. There we go. We got angles. So this little square here is going to be our guide. So let's... I don't know if I want it to touch this edge or this edge. So I kind of want to center it in between here. So I'm going to... So what we're going to do is we're going to extrude this. Can you not extrude with an offset? Oh, you can only if you do two object. Interesting. That's quite interesting. So I'm actually gonna move back here in time. We're gonna offset this plane. We're gonna go negative offset. Go forward in time. We're gonna redefine the sketch plane to be here. And then do want to go back in here. I don't like these references. So instead of there being a reference, I'm just gonna put the internal circle in there, so that way I don't have a reference for that. And I'm gonna hide this plane. I just noticed that the print on the A1 has totally failed. Like, everything just dropped off the plate. I'm gonna have to fix that real quick. Give me 1 second. I've never had an issue with adhesion on the A1. That's the first time that I've had this happen. I'm not really paying attention here, apparently. Look at this disaster that was happening. All right, we'll have to try that again. I'm gonna pop my webcam off real quick. Printer is heating up the room here. All right, let's start that print over on the A1 real quick. I'm not even gonna bring it up on the stream here, just because I'm just gonna throw a, like, if I had that happen in like normal printing situations, I would clean the bed because that's pretty much gonna be my adhesion issue. But I'm just gonna throw an outer brim on both of these just so I can start the print again without leaving to do that. And I'll turn bed leveling on too. All right, back to the regular scheduled programming here. Where were we? Okay. Oh, I'm running out of thought juice here now too. It's a disaster. We're gonna extrude this. We're gonna go the negative internal height. And then we're gonna do parentheses minus 2 times the offset. It's all math. Drawing, it's a lot of math. So, I don't know what construction plane this is. How do I turn that off? Oh, guess that went on the main sketch. Okay, so we have our one guide now. So we want to make a few of these. So I'm gonna just create a pattern, circular pattern. We're gonna select a feature. We're gonna select that extrusion. We're gonna select this axis. And for quantity, we're gonna do guide pin num. There we go. We got a good looking button. Now, if we turn on our case again, we go back to our main project, and then we turn on that section analysis. Ah, crap. Of course, like, the guides don't fall within the section analysis. But if we Yeah, so those guides are going to stick into the wall of the case. So eventually, I think I'll finish drawing the button here, but eventually we're going to have to use this button as a cut in the case, and that'll give us our guide rails for the button. But let's get to the more complicated part of the button. So let's turn that section analysis off. We're going to turn the case off. All right, let's create some parameters. So really all I need is number of teeth. Button teeth num. And we're gonna need 8. Now, this is complicated. To make 8 perfect teeth around this edge, it's gonna take some thinking. If you have any suggestions on what to do, you can put them in the comments. Like I said, you know, I'm not a professional CAD person, so I am just kind of guessing as we go. I'll tell you what I'm thinking, though. So what I'm thinking is I'm going to draw the button. So I need the button internal diameter, which is that outside line. I need the cam hole. So that should be sitting this is cam hole plus tolerance. Yeah, so that should be perfectly along the edges of our button. I can see nobody has commented on how to do this. That's a shame. Now I got to figure it out myself. Let's see. Well, we know that the side of each tooth, if there's 8 teeth, yeah, they should be 360 divided by 8, I think. Let me see if this looks right. So I'm going to draw this line here. I'm going to draw a line out here. And this should be 360 divided by num teeth. 45. Is that right? I think so. Yeah. Okay. I think I know what I'm gonna do. So I need to draw this line out here, and this is gonna be button internal. Sure, we'll just make it the internal diameter. We just want it to be outside of this circle. And then I'm going to draw a line out this way, and we'll make this the internal diameter as well. We're going to make the angle between these two 360 divided by the number of teeth. And then we are going to draw a line from the inside points that connect with this inside circle, and we're going to draw a line between these two going to make this line tangent with the outside circle. And how do I make... Yeah, how do I stop this from rotating? I want this to be... I want this to be I want it to be parallel. Okay, that's how I can constrain it. I want it to be parallel with this line. There we go. We're cooking here. We're cooking. I mean, I don't know if this is going to work or not, but we'll see. I see a few other people joined. Just letting you know what we're doing here. I have a series going on YouTube right now where I'm trying to design different models and put them up on MakerWorld to earn myself a free 3D printer. Right now I'm sitting at like $400, and I only made one video in the series so far. Most of the money has come from other models that I made in the past. But my most recent model was a gift card box that was like kind of a trick box that you could give people during the holidays, and that's doing pretty well. But I've noticed, like, looking through MakerWorld, that everybody is interested in printing like little fidget things or little trinkets. So that's what I'm trying to do. I'm trying to challenge myself to draw something that's very complicated, but at the same time, I'm trying to, do something that hopefully a lot of people will download. So I'm trying to imitate a pen click, but in a cylindrical fidget toy that you can hold in your hand. So right now, I'm drawing the cap, and I'm working on the teeth, which is quite a complicated procedure here. Okay, so here's my idea. Bear with me. I am going to put a plane at an angle on here, and I'm going to do it at 90 degrees. Right, and we're going to create a sketch there. Let's slice this. So I believe these are the 2 points of my triangle right here. Yep. So I'm going to draw I'm going to have to project this line in. I hate projecting things. I've mentioned that before, but I can't think of any other way of doing this. But I'm going to draw a line up here and a line down here, and then I am going to make these perpendicular. So that means that these are perfect 45s, a 90 up top, basic geometry. And I don't know if you could see where I'm going here, but I'm going to do something very similar to the outside line. We're going to slice. We're going to project. We're going to draw up, down, and then make these perpendicular. Now, why is this not constrained? Ooh. Look at that flaw. That was dumb of me. So I gotta make these sides equal to each other too. There we go. Well, I gotta fix that other sketch too. Do you see where I'm going yet? Do you see where I'm going? And I see that my A1 is printing, and it didn't kick the things off the side of the build plate, so that's pretty convenient. Alright, so what I'm going to do is I am going to loft this bad boy. And we're pretty close to checking if my math wasn't stupid. We're going to loft this to there. It's going to join. I don't know why this is like invisible. Okay. Yeah. Maybe it's just the angle I'm looking at it at. Okay. So we want to keep this sketch active here because we are going to trim this up a bit. So you're going to go extrude. We're going to select this profile. Select this profile and this profile. And we're going to go all. And objects to cut. Just the button. Done. There we go. We have a tooth. Now, I don't know if that's what the tooth looks like. You know, now that I'm thinking about it, let me pull this pen apart. Does it have a slanted edge like that? I don't think so. Which makes me think I'm going to have to do some modifications here. It's probably so tiny that I'm not going to be able to tell. It is really hard to tell. It's really hard to tell. I don't know. Anybody that is watching right now, do you have any opinions? Should I make this like a flat surface, or should I keep it slanted like that? I don't know what is preferred here. Like, I could drag this sketch to be second. And I could make this one visible. And instead of making this perpendicular, I could project this point and then put that one there. And that would make it even. I don't know what's preferred here. We'll leave that for now since I have it drawn that way. You know, like looking at the actual pen cap, it's so small, it's really hard to tell these like intricate details. I'm gonna say that's how it's drawn. Made the executive decision. Oh, like I said, this ain't easy. This is quite complicated. All right. Now we want to make a circular pattern with this feature. So we're going to pick our loft and our extrude. And we're going to select this axis. And we're going to do numb teeth. Did my math work out? Looks good. I just don't know if it has this slant to it. Like this whole slanty behavior here doesn't look right. Because like there's gonna be a cam that comes onto this tooth, and I don't think that is right. Let me go back to Let me go back to making this perpendicular again and see what it looks like with all the teeth. See, that looks like it gives a flatter surface for the cam to ride against. So I think I'm going to go that route. I didn't think I was going to go that route, but now I'm convinced. Boy, I feel like we're not even at the hard part here yet. And we're already, it's like an hour in here. Well, I got like a hard stop in like 30 minutes to an hour, so we'll see how far we get done here. I think I'm going to draw the cam. I think I'm going to draw the cam first. And then I'm going to cut out the like slots for the cam and the slots for the button in the casing. And then we still need a stick that goes up the middle that's spring loaded too, which my goal is to 3D print a spring, but worst case I do have a spring kit that I can use. So right now I'm actually going to grab another beer because I need some liquid courage to get into this next section here. So I'm going to let you watch the printer for a second. I'm going to run to grab a beer, and then I will be right back in a few seconds. All right, all right, all right. Oh. We are back. We are back and ready to go. Just gotta pop this beer open real quick. Perfect. Our print is almost done on the A1, so that'll help us check the threads. Like, watch, this thing's gonna be, not work, and then we're gonna have to go back and edit that, and that'll be, you know what? Let's not think about the problems we're gonna have. Let's just think about the future here. So for the cam, we're gonna have to start a new component, and this is gonna be called the cam. now. I'm trying to think of where we go from here. Let's see what planes I have here. Like the plane. Really, I'd like to start drawing from the face that I drew the teeth on and the button. Because then I was thinking I could extrude it out. Yeah, I don't know. Let's create a plane. Let me look at the cam first here. So I saw some others joined here. We're currently drawing a fidget toy. We're trying to draw something that is similar to clicking a pen. Nice little cylinder you can hold in your hand, sit there, click it a bunch of times. And it's part of a series where I'm trying to get a free printer from Bamboo from all their Maker World credit. So we will see how it goes. This is quite a complicated drawing. So the piece goes up. Yeah, the cam's got a stalk that goes up the button. So I need to make a plane at the end of this, at the end of the teeth of this cap. So what kind of tools do I have to create a plane? Plane through two edges. Actually, you know what I'm gonna? Oh, that's not gonna do it. Can I do a plane through axis through 2 points? Okay, I'll do that. So I'll make an axis between 2 points. So I'm gonna pick the top of the tooth on that side, and the top of the tooth on that side. So that gives me an axis to draw, or at least to put a sketch. There we go. So that's where our cam surface is going to start anyway. So we'll do that, and then we'll turn off our axis. All right. So we are going to make this the, we made like some cam hole, yeah. And we had a tolerance before. So that's good. So that's the hole that's gonna go, or like we're gonna make an extrusion up through the button. So maybe I should do that now. And what are we going to make that? We're going to make that the cam internal depth. Yeah, if we make it the internal depth, we're going to have space left because of the teeth. So that's good. We'll do that. And now we need to make the cam height. We'll make it 15 for now. Let's create a sketch here. We are going to do the diameter, button internal diameter. Finish the sketch. We'll extrude that. And we're going to extrude that our cam height. That looks reasonable. Looks very similar to the cap and cam that I have here in front of me. So we'll try and go with that. All right. So now the cam is interesting because it has a tooth that is half of the tooth of the button, and that's because this button cap pushes the cam, and then when the cam gets to a certain point, it falls into the next slot in the case, and that's how it translates the action to like a horizontal or a rotational force. It's very, very cool. So what am I gonna do here? I feel like I could do some type of fill. How could I do that? Like a boundary fill. Would be very interesting. Like, yeah, if I could somehow. Oh, yeah, but there's going to be a little bit of a tolerance in there, so that probably won't work. And that's going to be like the loft surface there. If anybody has any advice on how to start this, I'm all ears. Because I'm not 100% sure how I'm going to approach this part yet. The goal is I need to have 4 teeth on the cam, and they're only going to be half a tooth. Okay, I'm gonna ponder on that for a sec, and let's stop this print. It has reached a high enough height, so I'm going to cancel that print. You'll see the A1 stop printing over there. Print is canceled. Now let's pop this bad boy off and see what we got. So this filament needs to be dried, I can tell you that. Oh, and the plate's pretty dang hot. I mean, I literally just stopped it. So pull that off, pull that off. Put that back on the printer. Yeah, we got some botched up threads in here. I don't know if you can see that, but like there's some bridging and weird stuff that happened. And then here's the threads on the cap. They look alright. I think if I had a more dry filament, it would probably print a little better. But let's see if we can thread them in. Oh, I mean, that is sweet. Yeah, ignore the brim on here. I had to put that on there just for adhesion. We had an adhesion failure earlier that I've never had before, but let's rip all that stuff off. This is just a very quick print to test whether the threads that we designed are going to work. And I mean, that threaded on perfectly. So the big deal here, like, I didn't create threads on the inside of this cap here. I actually drew the threads on this cap. Or I didn't draw the threads in the case, but I drew the threads on the cap, and then I used the cap to subtract the threads from the case, and then I added some custom tolerances in for a 3D printer. And I mean, those threads are butter. Butter, butter, butter. So that's awesome. That means that, when I do my knurling around this case, and it's going to also be on the cap, everything should line up fine. One thing I do want to make sure of is that I align the cap and the case on the build plate to the point where the seams match up, or I can do a random seam or something. If I do a random seam on a piece that has knurling, like, it'll probably just blend it right in and you won't even see it. But awesome. I mean, that's a motivational boost. I'm starting to get down here as I'm running into drawing issues, but to have something go that smoothly, that is awesome. All right. Early success. That's what I'm talking about. Okay. Let's see. Like I said, I see like other people have joined. We're working on a fidget toy that it's going to be similar to a pen. It's a cylinder that you can hold in your hand. Fun, nice fidget toy that you can just sit there, click, 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 click. That's what the goal is. So far, we've drawn a button. We're starting to work on the cam. So there's the button and the cam, and then there is a case that goes around that, and then the case has a threaded bottom, and the bottom screws in just like that. So that's what we're working on. Let's get back into it. Let's get rid of the case, the cap. So we have the cap and the cam. And really the goal that we have right now is that we need to be able to draw a tooth on the cam that's going to fit halfway into this tooth. So it's going to be like a half tooth, and there's going to be 4 of them. Also, they're going to need to extrude outward. And okay, maybe I'm getting somewhere now. After thinking about that, maybe I'm getting somewhere. I'm thinking, what if I extrude a rectangle out at this midpoint and here, and then I use the button to cut that. And I'm also going to extrude it out even further than these guides, because the cam needs to ride in its own guide in the case. I don't know if that makes sense, but just follow along. I have an idea, and maybe it'll work. Maybe it won't. We'll find out. So cam, what is this? What did I call the other one? Button guide with button guide offset, button guide height. So I'll do cam guide height. And what did I make the button guide height? I think I made it 1 millimeter. Yeah, so I'm going to make this 2, maybe 2.5 to start. Okay. Let's create a sketch on the top of this cam here. And let's do a little slicey McSlice. Actually, I want to take away the slice here. Okay, so we are in the middle of a tooth on this line. God, now, like, the only way I can think about drawing this is drawing it in reference to the button. which I don't like that. I think I'm gonna draw this similar to how I drew. I'm gonna draw this the same way I drew the button teeth. I hate to do it, but I think that's the way to go. So I'm gonna draw a circle, which this is gonna be the diameter of the button. And we're going to draw another one that is going to be the hole. We're going to draw this out, diameter of the button. We're going to draw another one out. That's going to be diameter of the button. We are going to get the angle here, and that's going to be what, 360 divided by num teeth. So here we go again. So this is going to draw one full tooth. But my goal is I'm only going to draw half. I'm only going to loft half of it. So bear with me. We're going to get here. I'm feeling confident now. I still don't know how I'm going to draw the inside of the case unless I use these, like the cam and the button, to cut. And I might just do that because it's easier, but it's going to cause some references and stuff. It's not going to scale the way I want, but we'll see. So let's start by doing our thing again. So we're going to draw a line from here, from the inside here to the inside there. We're going to draw a line from here to here. It looks like it already did the parallel constraint. I just want to check to make sure. Yep, it already did. We're going to go tangent. We're going to hit OK. Let's make the button go away for now. We've already done this rodeo. Oh man, I made the sketch in the main sketch again. I've been failing with that pretty epically, but you know, I'm not perfect. I'm just going to accept it at this point. So now we're going to do a plane at an angle. We're going to do that 90 degrees. And we might as well just do it with this one too, 90 degrees. Start a plane sketch on this plane. We're going to do a little slicey McDicey. We are going to bring our line in, up, down. We're going to make these equal, and we're going to make them perpendicular. And now we're also going to draw a line straight down. See what I'm doing here? Do you see what I'm doing? I'm cooking. I'm cooking right now. Chef is in the kitchen. We're going to do it. We're going to do it. Going to project this line. Up, down. Equal, equal. Perpendicular. Line. Down. Now this tooth might align with one of the teeth on um, on the cap, and I think that's fine. I'm going to move this cam to the proper position before I do the cutting on the case. Like, this is going to work out to... Mathematically, this works out. That's all I'm trying to say. Alright, so we're going to loft. Why are we cutting? We're joining. We're making a tooth. Okay, so that looks good. Now, I don't have to worry about that inside because the cam is solid right now. But I will need to extrude this profile and make sure we're just cutting the cam. So that gave us our half tooth. So let's bring our button back. Yeah, see, I knew it was gonna get in the way of the button, but it's okay. No biggie. So now let's make our 4. Oh, yeah, you know, I actually did mess that up a little bit here. Let me do this second sketch here. Oh no, actually that's fine. It's not the second sketch. It was the first sketch that I did. Yeah, this sketch. So I actually want to take that tangent away and pull this out because I want to make a circle, or I want to offset this circle by the guide height, cam guide height. There we go. And now I want this line to be tangent with this line. So let's redo this loft now. So it's going to come out. That's kind of ugly. But I think that's the way it needs to be. So we're going to try it. We're going to try it. That's ugly, but it is what it is. And then the extrude was that. Okay. Now I should be able to turn all the sketches off. And I think... Yeah, this is where pens vary. Like, this pen does not look this way. But we're going to extrude that. We're going to extrude that down the cam height. Does that look okay? God, something looks a little wild there. I don't like that. Let me go back to the sketch. I think the tooth needs to be the same size as the tooth on the... Yeah, let me show you what I'm thinking here. So this was not smart. I think that this line does need to be tangent. I think this line does need to be tangent with this edge. But then I think I need to... I think I need to make a line that goes from here outward. Let's see what that looks like. Hold on. So that... Boy, now I'm confusing myself. This is not good. These lines don't mean anything because this is where the triangle is. So that... Pretty much I just need to blow this tooth out. See, like I need to extrude this tooth out. If you have any advice, leave it down in the comments below. How would I do that? Yeah, that's interesting. I mean, I could revolve something around and then pull it out and then extrude and cut. It doesn't seem clean though. Like, can I create a 3D sketch? Let's see if I can just draw some random things in 3D. Does it let me do that? Where's my tooth at? Like, can I draw a line from here? Is that 90 degrees? That doesn't look 90 degrees. Yeah, I want to draw from this corner. I've never done a 3D sketch before. I don't know if this actually works. But like, that looks good. Like, can I use that sketch and just extrude this face out? Nope, that doesn't work. Or let me see if I can. Can I like project? Yeah. Okay. That's not gonna work. 3D sketch is not an option. I need this guide to come out. How do I do that? I think This is a perfectly straight line, which means that face is perfectly straight. Like, can I create a sketch there? Let's turn the button off. Okay. So what if I draw a rectangle? Yeah, so what if I project this? I don't, I just did another projection again. And I said I didn't want to. Cam guide height. This is my only thought. Like, I don't know how else to do this. And like, if for some reason somebody's watching this stream like way after it happened or something, and you know how to do this, let me know in the comments. But this is very, very interesting. Profile axis. How do you reverse a 2? Like, if you want to go 2... Alright, I think I will have to measure this. Like, this is what I was trying to avoid. Like, when you do this super custom stuff... Here we go again with custom things. Oh, this is not a 3D sketch. D92. So we are going to revolve this around this axis. We're going to do a negative D92. See, I told you this is ghetto, but... I just don't like this approach. What do I do here? Can I split the face by these points or something? Axis through... Okay, axis perpendicular to a point at a face. So, like, that gives me an axis through that point. Okay. And now... Like, now I'm just straight up guessing. Like, how the hell do you do this? Now, can I split the face by these axes? No. Maybe I could put a plane through two edges. Okay, so now can I split this face with that plane? Done. Now can I just extrude that face? Or can I push pull it? Oh, I can. Holy. Guide. Oh, but it does extrude upward. Like, that's the same thing that we were doing. Okay. This just got an idea in my head. Let's go to sketch 4. All right. Hardcore focus mode. Like, I need to get this to work. This is so frustrating. So sketch 4 is that sketch. Oh, okay. Yeah, so I want to go back to sketch 4. Let's delete that, delete that. So I want another line. And we're going to make that tangent to this. And we're going to make it parallel to these other ones. I mean, freaking let me cook. We're going to get this. We're gonna get this. Okay. And then is that what I want? That looks valid. All right, and then if I extrude that, let's turn that sketch off. Distance to the bottom. That is a freaking complicated piece of geometry. I can't say if that's going to work or not. But geez, we're going to try. Oh. I don't think anybody has been watching in a while here. But if you are watching, whew, this is complicated and we're cooking now. We are cooking. So now we need to bring it around town. So we're going to do a circular pattern with that feature. And we need to make a parameter. Cam guide num. We're making 4 of these bad boys. All right. Now sorry, my brain is like fried now. Been doing this for so long. That's a wild looking thing. Okay. I mean, I would say the cam's done now. So if we take the cam and the button, yeah. So we're gonna have to move it to do what we want to the body. But let's hold off for a second here. Let's finish up. We need to add a param. Uh, cam stick hole. Gonna go 12. And then we're gonna do cam stick hole depth. We're gonna go 12. We're just gonna throw some values in there. See how it works out. Cam stick hole. That looks good. We're going to extrude that. You know, now I'm thinking about this, and it's like, do we actually want to put the stick up the cam? Like, that's not how this pen works, but that is how, like, Bic pens, I believe, are. Well, I'm just here alone, so it doesn't matter. I think, let's keep it simple. Keep it simple, stupid, unless we find a way, a reason why it should not be that way. So we're just gonna bail on that idea. Okay. Now what we're gonna do is we need to move so what I'm gonna do is I need to find the sketch in which we made the button tooth. Or actually I can do the sketch that we made the cam tooth. And I want to get this dimension. D105. So we are going to move we're going to move negative D105 divided by 2. So that should bring us down half a tooth length. And we want to shift over okay, so that's fine here. Capture position. Not sure what capture position does, but we're going to do another move. And we're going to rotate this. How come that move doesn't show up on the timeline? Okay. So if I... Okay, so the position is caught on the timeline here. So we're going to do another move. We're going to do this, and we're going to rotate. And we're going to rotate 360 divided by num teeth. divided by 4. Does that seem right? I mean, they're freaking touching. So I'm going to say that's right. All right. Now we have the cam in the proper position here. And we are 2 hours into a stream. Holy. What a freaking drawing so far. So we're gonna go back to the case now. And we're going to do a combined. Do you want to capture the current position of moved components? We want to capture them. We're going to pick our body. And for the tool bodies, we are going to pick the button. And we are going to pick the cam. And we are going to keep the tools. We're going to do a cut. Done. Okay, let's make our button disappear. Let's make our cam disappear. Let's do our cross-section analysis and see what it looks like in here. Okay, so that's looking good. So now when you press the button down, the cam's gonna move down. Yeah, I'm gonna have to really think about this. Okay. I think that this is a good spot to end. You know, we have almost the whole thing drawn. We have the case, we have the cap, the threads work great. We already tested it on the 3D printer. We have the button, we have the cam, and the last things that we need are we need to finish the case to get all the guides properly. And I have to do some thinking on this because, like, I'm not 100% certain how this is going to work. So yeah, I'll have to really think about it. But once I figure that out, then the rest is just once we get the cutouts in the case, then we need a spring mechanism, and that's it. Then we're done. So I don't know, like, I know we lost everybody pretty much at like the last 30 or 45 minutes of the video or of the stream. If you're watching this later as like a VOD or whatever, thanks for watching. This was a heck of a drawing night. Like, I hope you have a new appreciation for pens. They are extremely complex, apparently. So yeah, let's. I'll hop back on a stream again to hopefully finish this. But for now, thanks for watching, and subscribe. Leave any comments down below, and I'll see you next time.